Hi everyone, welcome to the channel, and today we're going to solve Leetcode problem number 515. Find largest value in each tree row. So first we're going to look into the problem statement, then we'll check out the approach which we're going to follow, and at the end we'll look into the code as well. And it will be a very simple code with I would say the best optimization as well. So let's start with the problem statement first. So they have said that given the root of a binary tree, return an array of largest value in each row of the tree. So for example, in this image, they have highlighted the largest value in each level with blue color. So level is this, like this is a level, then 3 2 is a level, 539 is in the same level, right? So what we're going to do is we're going to use the BFS approach to solve this question. So let's check out the approach what we're gonna do or what we're gonna follow. So we'll be using BFS approach, and for BFS we use queues. Okay, because queues give us the FIFO functionality to us, first in first out functionality, right? When we talk about the initialization, we will initialize a variable by name q, or you can take use any variable name for this, but this variable essentially will replicate the functionality of a queue. Okay, and we will initialize it with a root node because we'll have that as a starting point. And they have asked us an array of the largest node value in each level. So for example, this is level 1, level 2, level 3, right? So we have initialized an empty array over here. Okay, so now what we're going to do is for each level, by that I mean until our queue is empty. So for example, we started with root. We'll have a while loop. Okay, it will see, okay, queue is not empty yet. So what are the steps which I want to follow? So I'll first take or first count the number of nodes currently in queue. So for example, when in the first iteration we have only root, so the value of n will be 1. Okay, it will initialize a local maximum. Okay, local maximum is a variable name which I have used, so that I get to know that, okay, this maximum value is for the current level only. Okay, and I have initialized it with float infinity because everything will be greater than that, even 0 will be greater than that, right? So I have used floats to infinity, or we can change that as per the constraint in the question as well. Next part is we'll have a for loop running n number of times, and this n is coming from here. Okay, and what we'll be doing in that for loop is we will be popping out the element from the beginning, because what we wanted to do, we wanted to do FIFO, first in first out. Okay, so whenever you added any element in a queue, this will be the element which will be popped out, right? So this is exactly what we are trying to do over here. So we popped out, let's say, root. In this case we popped out root. Okay, next what we'll do, we'll check if the value of node is greater than local maximum or not. So for now my local maximum was minus infinity, and if we see in level 1 the value was 1, right? So yes, this condition satisfies. So what we'll do, we'll update our local maxima to 1. Okay, so this is done. Now next part is we want to add adjacent node into queues. So if you see over here, this node, like the root node, had two adjacent nodes, 3 and 2. So what I want to do, I want to add that in the queue now. So root was already removed at this point, we popped the root over here. So what it will look like, 3 and 2. Okay, so we did that. At the end what we'll do, we'll append the local maximum value to the result. So now result will look like this. Okay, next time we'll repeat the same steps until our queue is empty, and that will happen once we process this node. Okay, because this node will basically denotes the end of the structure, right? So this will be the approach which what we are going to follow. Let's check out the code. Okay, so this is the code for it. I have already wrote down the code. So as I said, I have initialized a queue by the name level nodes, and we initialized it with root. Okay, there is another variable called result in which we'll be storing our final result. Then we have a while loop. This is for checking, like this is for for running this code until our this queue is empty. Okay, so okay, for now, like we have any, like until the queue have any value, we'll count the number of nodes in it. Okay, we'll initialize the local maxima. We did that. And now next part is running the for loop, right? So what we are doing, we are running the loop n number of times. N was what? Number of elements in the current level. And at each step, what we are doing, we are popping out the first element because we are trying to use queue, right? And if node is not null, this is in check which we should definitely use to to handle any of the exception or errors. If node dot value is greater than local maxima, which was float infinity at the moment at the starting, what we are doing, we are updating the local maxima value with the current node value. And after that, as we said, like as we discussed in the previous, like in the explanation, we are appending the adjacent nodes into the queue. Okay, once this part is done, what we are doing, we are just appending the local maxima in our results, and at the end we are just returning the result. Okay, so this was the complete code which will do, which we should work. So let's check out the test cases quick. Yeah, so as you can see, the test cases got cleared. Let's submit it for further evaluation again. And the solution got accepted, and I would say, like, if we have performed fairly well, we have outperformed around 85.94% of the submitted solutions. So yeah, this was the solution, guys. Thanks a lot for watching out the video, and stay tuned with the upcoming ones. Don't forget to subscribe to the channel. Thank you.